Hi again, everyone. We're back to our Calc 3 class notes. We're on page 15 and we're looking at example 15. We're in section 12.4, which is the cross product, the second of our two types of vector multiplication. So using the information from example 31, find the area of the triangle with vertices, same vertices. So going back to the example 31, geez. Example 14, I didn't change that in my notes. I apologize for that. That was a big mistake. That's example 14, the previous one. Okay, previous example. Find the area of the triangle with those same vertices. Okay, so this is the triangle. Now, the parallelogram, a parallelogram would be twice that size, right? So the bottom line is the area of the triangle is half of the area of the parallelogram formed by the vectors PQ and PR. So it's half of the length of the cross product. So remember the cross product was 6i plus 6k. So that's 1/2 the square root of 6 squared plus, there is no j, so 0 squared plus the component of k, 6, so 6 squared. So this is 36 times 2, or 72. It's easier just to leave it as 36, 2 times 36, because the square root of 36 is 6. Bring out that 6, you get 6 over 2 is 3. You're left with the square root of 2, so 3 square root of 2, and then the units are units squared because it's an area. Okay, another type of interesting product is called the triple scalar, or the box product. That is because if you compute u cross v and then dot it with w, where I have any three vectors u, v, and w in that order, then what happens with that is it gives us the area, or excuse me, the volume of what's called the parallelepiped. So it's this box where the vectors u, v, and w form three adjacent sides. Okay, and then it's the box extended from those vectors, just like the parallelogram of u and v. So the area of the base is the parallelogram, which we know is the length of u cross v. So then I just need the height. Well, what's the height? The height is, okay, so the height is, I need to look at the angle between u cross v and w, because u cross v is perpendicular to both u and v. So that's what I want to do to find the height of this. So then I drop a perpendicular from where w ends over to u cross v. Okay, so what is that? Well, this angle, let's see. It's the cosine of the angle theta is the height over the hypotenuse, right? Adjacent over hypotenuse. Hypotenuse is the length of w. So in other words, the height is the length of w times the cosine of the angle theta. Now, we know height's positive, so I want to make sure I take the absolute value of that cosine of theta, because theta could be negative if it were the acute angle were bigger than 90 degrees. I'm sorry, cosine of theta could be negative. So how does that give us? The area of the base times this height would be u cross v, the length of u cross v, times the length of w, times the absolute value of the cosine of theta. The theta in between u cross, theta is the angle in between u cross v and w. So that's what this is. If I take the length of u cross v dotted with w. Now, that's not really length. It looks like length because I see vectors in there, but u cross v is a vector. When I dot that with w, it gives me a scalar. So what it means is take the absolute value of this scalar. That's going to be the volume of this, what's called parallelepiped, as you can see right there. So computing the triple scalar product is the easiest way to remember that is the same type of determinant we had as a mnemonic device for the cross product, except the first row is not ijk now. It's the components of u. The second row is v, the components of v. The third row is w, the components of w. Okay, so then you do u1 times this 2 by 2, which is v2w3 minus w2v3. So there's that. Then you got to remember there's a minus sign, and then it's u2 times the 2 by 2, which is v1 times w3 minus w1 times v3, right? The 2 by 2 that's not under u2. You get rid of that column. So it's this guy. And then it's plus u3 times v1 w2 minus w1 v2. So there's the formula written out, but the easiest way to do is remember this triple scalar product as a determinant. So using that, in this example, let's find the volume of the box, or really a parallelepiped, determined by the vectors u, v, and w. So I drew those semi-carefully, not real carefully, and I tried to visualize what that box would look like, and it's this guy right here. Okay, so how does this work? Again, you just take u cross v dotted with w, which is this mnemonic device, is this 3 by 3 determinant. I put in row 1 the components of u, in row 2 the components of v, in row 3 the components of w, and then I remember how to compute this determinant. So it's 1 times this 2 by 2, which is 0 times minus 4, minus 7 times 3. So it's minus 21 times 1. Then I've got to remember to put a minus sign, and then it's 2 times this 2 by 2. Minus 2 times minus 4 is 8, minus 0 times 3. 0, so just 8. So minus 8 times 2 is minus 16. And then plus the 2 by 2, so minus 1 times the 2 by 2 not underneath the minus 1, so it's minus 14 minus 0. So it's minus 14 times minus 1 is plus 14. So the triple scalar product ends up being minus 23, but the volume of the parallelepiped is the absolute value of that triple scalar product, which is 23. And then if the units were given, it would be units cubed.